Okay, this is page 606. We are doing, 606. We are doing 1 through 23 on this one. And okay, so we are multiplying um, with exponents. So let me do this is an example, not in your book, so I'm just going to put this up real quick. Um, okay, now what does 5 to the second mean? It means 5 times 5. What does 5 to the third mean? It means 5 times 5 times 5. So if you multiply those together, really you're multiplying 5 5s together. So 5 to the second times 5 to the third is like 5 to the fifth power. Okay? Okay. I should back up a little bit. This number on the bottom is called the base. Okay? This number up here is called the exponent, or sometimes we use the word power. You guys have heard that a lot. Base, power. Base is like the foundation, right? So the base and the power. So the rule is for this assignment, when you're multiplying the same base together, what happens is the powers just get added together. Now we could work this out and figure out what is 5 to the fifth, what's 5 times 5 times 5 times, or you could plug in your calculator just 5 to the fifth power and hit equals. But that's not what we're doing on this assignment. On this assignment, we're leaving it in exponential form, which means our answer is going to keep its exponent. So you'll see, I'll do number one here in a second. So on number one, the answer would look something like this. This is not number one. Let's go ahead and look at number one. So number one says 4 to the third times 4 to the fifth. Okay, again, we're not working it out. We're not going to put like 20,700, whatever. Okay, we're just going to say if I have 4 to the third times 4 to the fifth, well, how many 4s am I multiplying together? 3 plus 5 is 8. So it's just 4 to the 8th power. Okay, and we're stopping there just because the directions said exponential form. Okay, another example, that was number one. Let's look at number 4. Okay, same thing except for it says, let's see, x squared times x to the ninth. Okay, being letters, does that change anything? Nope, not at all. So I have 2 x's multiplied together times 9 x's that are multiplied together. So altogether I have 11 x's if you add those multiplied together. So just like the last problem, it's just x to 11th. Now that one you couldn't write as a normal number because we don't know what x is. So that's as much as we could do anyway. So x to 11th is the final answer for number 4. Now I need to back up a little bit because I see an issue. What if it had been like x times x to the fifth? What would that be? And this would apply to like number 3. Well, if there's no number up here, what does that mean? If there's no number, the exponent is like a 1, okay? So x to the 0 would be worth nothing, kind of. It would be, technically it's worth 1, and then 1 times whatever would just be whatever, so it would just kind of go away. But anyway, if there is no exponent, the exponent is a 1. Kind of like if there is no number in front, we just say that's a 1x, right? So same thing on exponents. If they don't put an exponent, that's like the first power. So this example is x to the 6th. Okay, it's not a real problem. It's just an example. So you're going to need that on a few of the problems today. Like number 3, for example. All right, let's jump to number 7. All right, it says 4x cubed times 2x to the 4th. Did I copy that right? Yeah, all right. So because the order of multiplication doesn't matter, like 4 times 2 times 3 and 3 times 2 times 4 is all the same. We can, when we have a bunch of stuff multiplied together, we can just multiply whatever we want to together. Kind of like adding. If we got a bunch of stuff added together, just add whatever you want to first. So I don't know what 4 times x cubed is. I can't do anything. But I do know what 4 times 2 is, right? That's something we can do. 4 times 2 is 8. And then x to the third times x to the fourth, I can simplify that a little bit, just like number 4. x3 times x4 is x7. Just add the exponents together. So notice on the normal numbers, I did normal multiply. What's 4 times 2? 8. But on the bases with exponents, when I multiplied those together, I added the exponents. Okay, it's different. So if you put x to the 12th, this one would be wrong. So the exponents work differently with multiplication. And notice I'm not doing like x to the third times y to the fourth. Okay, that doesn't simplify. It's not 7 of anything. So those would not simplify. You have to have the same bases multiplied together. So that's it for number 7. Okay, just as another example from that section, I'm going to look at number 11. No, I'm going to jump. Let's jump to 15, I guess. Okay, so nothing new. It's just the same as 7, but it's just a little bit bigger. So I'm going to do -8 times 3, and that would be -24. One negative, when you multiply, makes a negative. Okay, and then I got x to the 7th times x to the 2nd. What would that be? That would be x to the 9th. So I put my x's together. Now my y's, I got y to the 4th and y to the 2nd. That would be y to the 6th. And that's all we could do on that one. Okay, now the last section I only assigned 3. Maybe I should have done more, but let's do let's just do 22, I guess. I'm gonna have to erase something. -5x cubed x fifth plus 2 cubed. All right. So this one is different. The difference is there's 2 terms inside this parentheses, so I can't just do -5x cubed times this. I've got to multiply times both of these. We've done this before. It's called distributive property. We just didn't do that. We haven't done the exponent thing before. So I need to multiply -5x cubed times this plus times this. Okay? So let's start at the beginning. -5x cubed times x to the 5th. Well, the -5, there's not really anything to multiply it with. You could think of a 1 right there. -5 times 1 is -5. What is x cubed times x to the 5th? X to the 8th, okay? Plus, now normally a plus would go down here, but if I did -5 times 2, that would be a -10. So that's, instead of putting plus -10, I'm just going to put -10. Okay, plus negative is just like a minus. All right, and then x to the 3rd times x to the 3rd, what would that be? X to the 6th. Okay, now, do these two go together? Can I simplify anything? The answer is no. You can only add or subtract like terms. Since one is x to the 8th, the other is x to the 6th, can't do that. So this is the final answer for 22. All right, so we're going to 23 on that one. Good luck with that.